Hi everyone, I am Yogadharani, working as Assistant Professor in Department of Computer Science and Engineering at SNS College of Technology. And in this session, I am going to discuss with you application of graph, that is a traveling salesman problem in data structure. And this is my session plan, a recap, content delivery, activity, and summary, and the assessments are going to be discussed in today's session. So recap of this session is, and I already discussed you with what are the graph basics or node. Graph must contain edges and number of nodes, and two nodes are connect between the edges. And types of graphs are weighted graph, unweighted graph, um, directed graph, undirected graph, and BFS stands for birth first search, and it has the principle behind this Q, and DFS stands for depth first search. In the search, we working principle with the help of stack, and the advantage behind the DFS, it has the backtracking method. And objective of today's session is um, I'm going to tell you about detailed about traveling salesman problem. So imagine that it's a bright morning in a Coimbatore. A delivery driver named Arjun works for a major e-commerce company, and he has to deliver 20 packets across different locations like Pilamidu, Sai Baba Kalli, Ganapati, and more. And his challenges, he can he cover all the areas and visit each customer exactly once and return to its starting point. Uh, and while using this with the least fuel and time. So, define of my problem is here. I have given a set of cities and a distance between each pair of them, and our task is to find the shortest possible route that visits each city once and return home. Here, explain this with one of the boldest and most richer problem in graph theory, and with applications everywhere from the logistic source here the 5 cities connected by the weighted edges. Next one is the activity part. Here I am given a role play for this problem. Here let us make this real in here. Each group represents a delivery company, and each member of the group in a city on a table you have a distance matrix, and your job is to find the shortest delivery route manually and try to first for 4 cities and then see the problem here. When you try all the paths and you are doing brute force, and that's the factorial time of 0 of big O of n factorial for this. uh, Next one is my one, and here what is the idea behind of my problem is here brute force. Here brute force is that for a particular problem I have to solve each and every path of that is try all the path, actually accurate but impractical. And then the second one is dynamic programming. Here I'm that is my analysis must. So in what the next the nearest neighbor, and it is mainly used in machine learning for classifying the data sets, and the algorithm is k nearest neighbor, and then minimum spanning tree, and then dynamic programming. So dynamic programming balances the precision and performances, and then modern genetic algorithms and Ant colony optimization are used to ideate my problem. Prototype. Here I'm showing a graph of 5 cities, that is 0, 1, 2, 3, 4 likewise. Here students walk through the nearest neighbor example at S starts with the A, choose the nearest city and continue, we return to the start. Here this shows the optimal path with the from 0 to 2 it takes 10 cost to travel, and then 2 to 1 it holds 15 as a weighted one, and 0 to 3 it has a 12 weighted graph, and 1 comma 3 it has 11. So likewise I have to travel the all four vertices 0 1 2 and 3 with the minimum cost. This is my prototype of the problem here. And then technical depth is here a graph representation. While using this traveling salesman problem, we have to follow the adjacent matrix. See here there are the six vertices. From one I have two outgoing, two out degree vertices from 2 to 3. So mark it as 1 in second row. In second column I mention as 1, and third column to mention as 1, and other vertices are remain 0. Likewise from 2 vertices to it has the out degree from 2 to 1 comma 4. So I mentioned there. Likewise I have to maintain the adjacency table. Next, interdisciplinary and future scope. It must be, it has the used in logistic and supply chain for routing, scheduling, and supply chain optimization. In biology, it is mainly used for DNA sequencing alignment, and also it is used in ANML. So summary of the session is, in this session I discuss with you guys what is a traveling salesman graph and how to ideate the problem by using brute force and then applications. So this is the mind map for a traveling salesman problem. So in next video I see you on another topic. Thank you all.